So here we are with the last four questions. I'm going to do them down at the bottom. So which one is the seesaw? Once again, you have to draw the picture. So let's take a look at SF4. All right, so you've got 6 and 28. That's supposed to be an F. And 6 and 28 is 34. So you got 34 valence electrons. So you'd have S, and then 1, 2, 3, 4. And I didn't go through all the steps. So 34 minus 8 is 26. That gives you 24 dots to put in. If you're really on top of this, you can tell already that you're going to have 2 extra. Now sometimes students will put, when you have 2 extras, they think, oh, I'm supposed to put a double bond in. But no, when you have extra ones, they go around the center, like that. So what that really means is that this is not what the shape looks like. The shape is like this. You see this triangle here is in a plane in the center, and then you got a fluorine at the top up here and a fluorine down at the bottom, and then these guys are all on the same plane. All right. Oh, but there's only 4 fluorines. So instead of having a fluorine out here, what do you have? That's where your unshared pair of electrons go. Okay, so this pair of electrons right here is that pair out there. So now if you turn this thing on the side and do it this way, you see how you have a seesaw? And that's the answer. The one that's a seesaw is this one. If you draw CCl4, it's going to just do this. I started to draw it tetrahedral and didn't, so there you go. All right. All right, so there's your tetrahedron for CCl4. BRF4 minus might be interesting to draw. SiF4 will be just like CCl4. Let's do BRF4 because it might be fun to look at it. So BRF4 minus. So you've got 7 times 4 is 28, plus 7 is 35, plus 1 is 36. So you had the BR, and then you got the F's coming off of it. You put the less electronegative in the center. And how many did I say? 36? So 36 minus 8 gives you 28 to put in. So you start putting them in. It only takes 6 per outside atom to make it have an octet. And then you're going to have 4 more that I haven't put in. So right now, I have 32 electrons in this picture. So then I have to put 2 more in here and 2 more in there. So what happens is those guys are in a plane. Oops. In a plane sort of up above it, like this. Maybe I can make it so you can see it. Yeah. Let's try this. So an arrow there, back to there, there. There you see the pyramid sitting up on top. So there's a pair up on top. I'm going to stop there because I'll mess up the bottom picture. But you can get the feel. There's a pair of electrons above the plane and a pair of electrons below the plane. But the plane itself is a square. So that's a square planar molecule. All right. So that is number 23. 24, which one has sp3 hybridization? Well, sp3 would be 4 domains. You see this has 6 domains. This one has 5 domains. But both B and D have 4 domains, and that would be sp3. Which one has resonance? Once again, you've got to draw the dot diagrams. There will be one which has a double bond that could go in multiple locations. So we'll just take a quick look at CH2O compared to NO3. BRF3. BRF3 will be a T shape, I'm pretty sure. Let's see. It'd be 7 times 3 is 21, plus 7 is 28. Take away 6 gives you 22. Here, we'll just do it real quick. So BRF3. Okay, 28 minus 6. 7 times 3 is 21, plus 7 is 28. So 28 minus 6 gives you 22. So I put 6 around each fluorine. 6, 6, 6. That's 18, 19, 20, 21, 22. So it's in 5 domains. It is a trigonal bipyramidal. Of the 5 domains, 3 are shared or bonding domains and 2 are unshared or non-bonding domains. So that means it's a T-shape. That's the molecule. Incidentally, I'll let you use that sheet on the test on Monday. Then the one I think would have resonance, we need to compare CH2O. It's going to look like this if you draw it. And NO3 minus, which looks like this if you draw it. So in this one, the double bond could have gone here or here or here. So it could be in any place. Here or here or here. Down here, the double bond can only be there. And the reason it can only be there is because hydrogen cannot have a double bond. So therefore, this is not resonance and this is resonance. So the answer is NO3 minus. And then which has the most pi bonds? Once again, you've got to draw the dot diagrams. Somewhere earlier, and by the way, we'll assume no expanded octet, because if you expand the octet, I think you'll find there may be more than one answer. But assuming no expanded octets, the answer is going to be HCN, because the dot diagram is going to look like this. And that is going to have 2 pi bonds. Remember how the pi bonds look. So if I'm actually going to draw the bonding in this, I'll just make one here. Okay, so around the carbon, it bonds with the H out here, where this kind of overlap, where there's a straight line, so that's a sigma bond. This is the carbon in the center. There, come on. So there's the carbon. And then the nitrogen is out here. The nitrogen is going to have a sigma bond orbital this way, and one. There's no bond out here, but the electron in that unshared domain is going to be right here. That's that pair of electrons, because that's in. Okay, then the actual pi bond forms like this, and these guys overlap. But that is 1 pi bond. The other one is perpendicular. Try and draw those out in the plane. And they connect here and there. So now you have 2 pi's and 1 sigma. All right, hope that was helpful. That was a little test review. And I'll check the question and answer page and on the homework site if you want to write something out for me. All right, that's it. Have a good Thanksgiving. Bye-bye.